Alright, welcome to the lesson about end behaviors. This lesson actually includes the last three properties that we're going to be talking about with functions this year. There's end behaviors and then asymptotes. And we'll get to what asymptotes means later. But let's start with this kind of starter activity thing. So this one, suppose you're in a possibly large roller coaster. It contains unbounded directions. Let's start -2 on the x-axis, so that's here. And you are either going to go left or right forever and ever and ever. Well, first one's asking, what height do you start at? So if we assume our y-axis is height here, which is a good assumption, we're right on a y value of 0, so we'll start at 0. Let's call them feet. If you go left forever, what height would you be going towards? Well, let's drag this guy and go left. Looks like you're going down forever and ever and ever, which means your height keeps decreasing, going down. The y value, or the height, is going down forever, so we're going to put -infinity. And y is because you're going down forever. And I'm not going to bore you by writing that out, but yeah, because you're going down forever. Next one, if you were to go right forever, what height would you be going towards? Well, let's go back to this and hold on. I need to highlight this guy. So if I go right forever, so go down, and it goes back up, and it doesn't really have a turn after that, and so it looks like it's going up forever and ever and ever, and so I'm going to put positive infinity because the y value increases without bound. And on the y part, you can explain that part. Again, I'm not going to write out all those words because I don't want to bore you. To have you just watch me write words that I'm saying. Yeah, so go ahead and write that out. Make sure you got your words there. Don't put scribbles, put real words. Then, which direction do you want to go? And I would love to have you guys respond to this in person and explain why you really want to do that. But I'll share some kind of the answers people put previously. I've had people who say they want to go left forever because they don't want to, go up into the cold darkness of space and, slowly suffocate from lack of oxygen and things like that. And then some people argue that if you go left forever, you enter the core of the Earth, which is kind of really hot and deadly that way. And so they prefer the going up forever into the atmosphere and into space and dwell amongst the stars. Definitely dead, but yeah, in the stars, I guess. And so you can kind of decide how you want to go with that. One direction is really hot and one direction is really cold, so you can decide, I guess. But anyway, but yeah, that's pretty much an example of what end behavior is. If you were to go left along your function for forever, what happens? And then on the right side, if you go right forever on your function, what happens? And that's what end behavior is. So this would actually be an example of left end behavior, and this would be an example of right end behavior. And to write your actual answer on your assignment today requires some kind of weird notation with this weird sentence, but it's very mathematical in nature and it explains what's going on. So the left end behavior is stated this way, and you're going to write this down every time it asks for left end behavior. And let's interpret these symbols. So it says as x approaches, let me write that out, -infinity. You know what, I'm not going to write out all those symbols. Let's do the arrow part. As x approaches -infinity, f of x approaches, and that's what the arrow means. The arrow stands for approaches. And so what this is saying is as your x's go more and more negative, meaning as you go horizontally left, this part tells you how high the function's going. So on the left side of our example at the beginning, it was going down forever. And so if I were answering for that one, I'd put -infinity here. On your assignment, you will always write this phrase. It starts the exact same way every time. As x approaches -infinity, f of x approaches, and then you fill in the blank. And that's how you finish up the end behavior for left end behavior. The right end behavior is almost exactly the same, except this. Well, on the right side of all functions, if you go right forever, your x's aren't approaching negative infinity. That's left. Your x's are approaching positive infinity. Remember, if you think about a number line, if you go right forever, you're approaching positive infinity with your x's. Well, if you look at your function, you can see how high it's going. So remember, these are like the y's. What are the y's doing as you go left forever versus what are the y's doing as you go right forever? Not all functions just go to negative infinity and then positive infinity. Some of them go up to 3, and some of them go to negative infinity on the right side, and that's totally fine. But remember, you always start with the same phrase, and the only thing that changes is the blank at the end. So let's practice this on some functions that you've been seeing. So if you look here, we got our functions from our notes. We got our A, B, and C, kind of our favorites around here. And on this one, on A, I want you to think, if you go left forever, how high up will you go? Well, this is going up forever, so your function is going to go to positive infinity. If you look here, it's got the phrase, as x approaches negative infinity, meaning left, f of x, the y's, approach positive infinity. Well, if I wanted the right end behavior for my A function, I just go right forever and think about, well, how high up is this going? Well, it's going down and down and down and down and down. And so I'm going to put negative infinity. The y's are approaching negative infinity as your x's go to positive infinity. So that's my end behavior there. So I want you to see if you can fill those in for these other two graphs. What happens on the left side of here? What happens on the right side? What happens on the left side? What happens on the right? If you could go left and right forever. So pause and fill that in. Alright, let's look at this exponential one, graph B. Remember, this is decreasing, 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 but it never actually hits this line here, which that y value is negative 4. So actually on the left side, it is approaching a height of negative 4. And on the right side, it's going up forever, so I put positive infinity. And then this function here, on the left side, is just going down forever and ever, so the height is approaching negative infinity. And on the right side, it's constant. It's at the same height here, which that height is 2. So on the right side, it approaches 2. You could actually say it equals 2 if you want to make it more precise there. It just is 2 on the right side. So those are the end behaviors. Let's start with end behaviors. Practice on a few of these things. Let's go to problem 4 and 5. Remember, when you're writing down left end behavior, it always starts with the exact same thing. As x approaches negative infinity, f of x approaches, and then you fill in the blank. Well, on the left side of this function, how high up does it go? Well, if you go left, it just keeps going down forever. And so I'm going to put negative infinity. The y's go to negative infinity. Let's do right end behavior. As x approaches positive infinity, that's to the right, f of x, or our function or y values, approach. Well, if you go right forever on your function, it looks like it's going down forever as well. And so I'm going to put negative infinity again. On both sides of my function, on the left and right, it is going down forever. So that's my end behavior there. I want you to see if you can get your end behavior on the right one. If you haven't done that yet, go ahead and pause and do that. Alright, so hopefully on your left end behavior you started with as x approaches negative infinity, f of x approaches. It always starts with that anytime you do left end behavior. Well, on the left side, this is going down forever, so I put negative infinity. On the right end behavior, this is going up forever, so the y value there is approaching positive infinity. So now you've seen kind of a few examples of this end behavior stuff. Let's go back to this last blank, which we didn't deal with. And this is a kind of interesting word. It's asymptote. You should try saying it a few times. It's not a swear word, I promise. Asymptote. 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 You just get it out of your system, asymptote. So an asymptote is a line that your function gets infinitely close to. It keeps getting closer and closer and closer, but doesn't actually touch or cross it. And actually, most of the functions you're looking at do not have one of these. This does not have one, so I'm going to put none. This also does not have an asymptote, so I'm going to put none. But this one does. Remember how in exponentials, it keeps getting closer and closer and closer and closer, but doesn't actually hit it? That is an asymptote. So my asymptote's actually right here. It's this line. And that line has an equation, and that's what you're writing down. Luckily, it's a horizontal line, and all horizontal lines have the equation y equals some sort of number. And if you want to know what number that is, just find the y-intercept. It's that number. And so here, I'm going to write y equals -4. Because here on the left side, it's getting closer and closer and closer to the line, y equals -4. And so, if we look at the examples we were looking at, neither of these have a line it's getting infinitely close to, but doesn't cross. And so, we're going to put none on both. Or you can put NA. That's also acceptable, not applicable. But if we jump over to 2, 2 does. And I want you to pause the video and see if you can write out the equation for this line it's getting infinitely close to, but doesn't touch or cross. If you wrote down y equals 0, congratulations. Yeah, it's a horizontal line at a height of 0. If the line was instead up here, let's say it was here, then you write y equals 6. If it was down here, you write y equals -3. It's just whatever the y value of that line is, that's what you write. Y equals that. And I want to mention that your asymptote is actually related to your end behavior. Because here on the left side of my function, it's the one that's approaching it. So if I were to write out my left end behavior as x approaches -infinity, f of x approaches. Well, on the left side, it keeps getting closer and closer and closer to a height of 0. So I put 0 there. And, a 0 that actually looks like a 0 instead of a 6. And there you go. So that's kind of what end behavior is and what an asymptote is. Just so you know, only a few of them have an asymptote, and it's primarily the exponential ones. Because exponentials get closer and closer to some number on one side. So there you go, final properties for our function properties unit. Good luck.